Hey everybody, this is Mr. Beckstrom, and today we're going to take a look at finding the derivative of a function at a certain x value using the limit definition of the derivative up here. So let's go ahead and get started. Now sometimes you might see the x as an a. In that case you'll see at a equals 5. But just know that a and x are just placeholders for the x value in either case. It's the h that we always want to leave alone in the problem and then cancel out at the end. So let's take a look at how we can do this one here. So let's start off. We're just going to do the limit as h approaches 0. Now, this here says we go to our function and we replace x with an x plus h. So I'm going to go over here to this first function and I'm going to do the -4, and then instead of x, I'm going to put x, oh, that's a horrible x, huh? Let me get that a little bit better here. All right, x plus h, and a little plus there. And then that's going to be -7. All right, and then we're going to do the minus here from right there. So minus, and then f of x is just this function here, and I'm going to put it in parentheses so that way I remember to distribute that negative sign correctly. 7. And this is going to be all over h. All right, so that's the first step. We're just following this. Again, this function notation says go to your function and put it down, but just replace whatever variable you have with x plus h. And then this is technically replacing x with x, which doesn't actually change anything, and then all over h. Now, if we were to put this 0 in for h right now, we would get a 0 over 0, which is the indeterminate form. And that means that we usually have to do some manipulation to try to change things around and hopefully get rid of this h in the denominator. So let's go ahead and first start by just kind of distributing everything on top. So the limit as h approaches 0. So distributing that, that's going to be -4x. And then -4 times h is -4h. And then -7. And then negative times a negative is a positive, so plus 4x. And negative times a negative is also a positive, plus 7. All over h. Now, notice that once we do that, we're going to get some stuff that's going to cancel out on top. So we have a -4x, and we also have a positive 4x. I have a -7, and I also have a positive 7. So all I'm left with here is the -4h on top and the h on the bottom. So let's rewrite our limit here. As h approaches 0, we're going to have -4h all over h. And notice that the h's will cancel out, just leaving me with a -4. So that's actually my derivative, -4 for all x values. And remember that derivative is the slope of the tangent line at any point on that curve. If we go back up to the equation here, notice that that's a linear curve. So that means it's a straight line with, this is in slope-intercept or y-intercept form. So the -4 is our slope of that line. And in linear cases, our slope is going to be matched by the slope of the tangent line as well for every point. So now we said evaluate this at x equals 5. Well, so first of all, the derivative, which I'll put f prime of x, is equal to -4 because we just plugged in the 0 for h, which there was no h's left, so we didn't change anything. And if we put a 5 in here and we look at f prime of 5, notice that there's nowhere to put that 5 in here, so that just still remains 4. Excuse me, negative and negative. And so that's our answer. Um, our derivative, which is the slope of the tangent line at the x value of 5, is equal to -4. If you have any questions, please let me know, and good luck.